It is time for science. Perfect, we're live. We got a lot of stuff to do today. I had nothing to do all day except fix carbs and eat my meals. So the goal is going to be that over the next roughly 12 to 14 hours, we have hyperparameter sweeps like in a good spot for all of RL. That's going to be the goal for today. This is good. There we go. Gotta do a little bit of promo here and there. Okay. So, this is right here. This is the baseline that we trained from yesterday. So you can see that it works. 10 bil is the max total time steps. It's also based on the synthetic benchmark. This is what we want. It took longer than it should have to get here, but it did get there. Batch size is correct. I don't know why it's sampling down here. This is kind of weird. Mini batches, also correct. Learning rate is a little bit low, but pretty well spot on. Gamma 0.99, very good. And then this is averaging 0.95, very good. Update epochs is correct. BPT horizon is wrong. I don't know why this is. And then num-ems should not matter for our function. Okay. So I'm trying to think what we want to do here. These Neptune runs are nice, but they're very slow. I kind of just want to do a quick, like, local plot thing, because we really need to test this way faster. Breakfast will be in like an hour, and then I'll be back for 4 or 5, lunch, back for 4 or 5, dinner, back for 4, you know. That will be the deal today. I'm going to try to rewrite a lot of the carbs code as well, I think, because it's a mess. They did a really good job on the algorithm and the results, but, you know, engineering is engineering. That is my department. I'm trying to think how I want to do this. I think I can just do... Yeah, I'm going to do... There's GPT. I'm going to cheat on just like a couple small things and use... or be lazy. Just for a few things I'm not familiar with. Yeah. Basics. Yeah. Possible. Okay, perfect. This is all we need. Test carbs. Ugh. There we go. I don't know why the hell that was so hard. Okay. So we'll do scores this. Just do scores times score. And okay, let's see what this does. Because I'm sick of waiting so long for this basic test. I'm on my local box here. Is that okay? Hang on. Looks like it should be okay. No, I'm on the wrong. Okay, I need to get onto. I need to go grab the code off of my main box. Yeah. I want to do this locally. So I can plot. What in the hell? Oh. I don't know why it's building HTML there. Okay, perfect. So let's get rid of this. And let's just like get rid of all these extra confusing terminals. I have all this. I really should have just rebooted before I started streaming, but whatever. Okay, this should be good. And next, get the ablations code. Okay, perfect. So let's see. Let's see if this works. Get Plotly. I think it's still not going to be super fast because carbs fits a model every iteration. Try this. Operation not supported. Okay. I guess maybe I do need to do this in a local plot. It's kind of obnoxious. I mean, I can just honestly print the damn score, to be honest. It's not that big a deal. What the hell is this operation not permitted? Like, what on earth? Am I on the wrong box? Oh. Alright. Okay, cool. So here we have this. Score. Okay. Ah, something's weird there. They came back with the same score a whole bunch. Must have sampled the same point. It does still take it as quite a bit to sample. It's faster than before at least, but... Okay, so I mean, maybe we'll look at that as well, because it's kind of silly for it to be taking that long to sample. We'll let that run in the background. So now we have just like CLI version of this. And since we're going to just be short morning session before breakfast, the main thing I want to do is I want to just figure out exactly how I want to restructure all this code and stuff today. We got min bound and max bound. Compensate for floats being bad bounds for integers. Compensate for floats I don't think that's a thing. And then this rounding factor is also kind of silly. Okay, so this is working as before. You can see here. It's very nicely finding better and better results over time. Yeah, there's just like a lot of extra jank in here that's not needed. I think what we're going to do is we're just going to restructure basic, round tensor, and basic. I don't know if they actually need this rounding. Okay, so they got a fair number of things here for rounds. A lot of this stuff we don't really need to care. Is saved. I think what we would want to do with this is instead of having carbs be responsible for saving itself to a specific backend, we just make it really easy to get and load the model in. That would probably be better. I'm going to let this run so I make sure that this is good. I'm going to be right back, 10-ish minutes, and then we'll start on this for a little bit before breakfast. Okay, we are back. Perfect, look at that. 250, 260, exactly as intended. So this is our baseline right here. This is going to be our baseline. And we have it in Neptune, the exact same thing. Okay, there's just so much crap in here. Checkpoint. Like this 1B runner is actually, it's kind of nice what they have. Like the functionality is good, but the code's a mess. Why is it this complicated? Let me see. 1B restore. Load latest checkpoint. Oh, they're checkpointing like all the carb. Okay. I'm confused because I don't even think this thing does multi-node, right? Look, I don't know. We'll figure out multi-node later. We're gonna get good single node working and ignore this shit for now. I'll put it back later if we need it. This is silly. We're gonna just start cutting code here. Better. And then these things have me in as well, right? Okay. So min, just gonna do min. Oh, it's crazy. Fun. Next thing I want to do is figure out the sampling. I should probably make sure I didn't break it first, right? I should probably get this to run as is. Okay, so that actually is good stuff that I'm deleting here, but I don't want it linked to 1B. So we'll redo that better later. And looks like it runs. Okay, here we go. Round tensor in basic. I don't think that this is needed, so I think what we're going to do is we're just going to get rid of it. Let me think. I could see it kind of being useful, but I don't think it's needed. We'll see. The thing is, like, it's generating samples and then ranking them, so yeah, kind of. But if you were to just generate the samples, I don't know, maybe we'll consider adding the rounding, we'll see. But I don't like the way that they were doing it. It's very error prone. Can we actually just see if this is the exact same as before? It's not the exact same. Okay. It's actually a way higher. See if this is any good. And then the next thing here is going to be generate candidates. Okay, so this is this is not great here. Get probabilities in search space. What the heck is this? Okay, there, that's working. Yeah, so you want the parameters here because you need the scale for sampling. Oh yeah, look at that. We're at 140. This should be good. I'm confident that this is working. Let's see. Where are the parameters? So this is origins in basic here. You can see they're nicely normalized. It didn't give us the sample. Basic space to param space. Basic space to. Suggestions in basic. Where the heck is the real number input is X? Search distribution in basic. Where was the frickin'... There should be a dim here. Where's like the... We want to get the per variable dimension. Okay, here's dim.min. Min bounds in basic. Hey, Linky. Oh, wait, maybe I can do this. Scale in basic. Maybe I can do it like this. Linky, I'm thinking of doing the microcode updates either today or tomorrow, depending on... I want to focus on this for now. But are you around at some point? Like, I don't know if there's anything I need to know other than just, like, go stick it on a flash drive and try not to screw up the machines. I'd like to get all the machines nice and stable. I'm going to be placing an order for our first 5090 box on Monday. And then that'll be the test box, so whenever we get those in. And then in 2 to 3 months, we'll have the likely 2 to 3 months we're looking at for the big cluster. So carbs is coming in handy here. It's going to really let us get a lot out of that compute. Wait, search distribution in basic. This is it, right? Yeah, so this is bad right here. So this is going to be self dot search is normal. Let me see if you can do this. Really? Ah, it's because it's just dim.scale. Okay, so search distribution basic. Very nice. Dot size. Yeah. Look at that. That's perfect. So this will run almost. DM the motherboard of the boxes, and I'll look up. They might have different motherboards. Let me see. Let me go look that up real quick. I should have the order history. I'll just put it in Discord or chat or whatever. Let me see. Go check my main gear order. I just got an email from a VC, just like lots of snakes. Played with your snake demo. Can we help? It was funny. I'll need to know which motherboards, and you'll need to be sure that they install to the. Yeah, let me go. I'm looking right now. I got distracted because I just opened my work email and I had like a ridiculous VC email. It's funny. And it's effective. Got my attention. It's so funny though. Lots of snakes. What's this box? It is the Risen one. Oh, they literally sent me a BIOS update guide. Let me see what motherboard it is. The one thing I can't find. Actually, can you just list it? Is there a quick way to just list your motherboard from console? There should be, right? I know how to list your CPU. Okay, I found main gear. Oh, that's for 2 boxes. Okay. Yeah, so the newest ones, it's let me send you this, and then we'll get back to carbs, because there's all sorts of carbs to be done. Uh-oh, that's not good, is it? Oh yeah, we'll fix that, fine. I'll just put this in Gen Chat. I think they did send me a guide. One second, folks. The hell's this on? I just got sent an awful piece of code. Let's see. Yeah, I can show this. This is just E3B code. I implemented this thing yesterday and I got sent a reference implementation. It looks awful. I don't even see where they call this. I mean, this can't be good though. Is this their entire... Yeah, this is what I do. I don't know why they have any of this. They shouldn't even have any of these. Okay, so it is a no grad. Let me think if we can do this. I think we actually might be able to do this. Yeah, I think we actually can. So this implementation makes no sense to me because this loop shouldn't be there. Okay. There we go. Just had to answer one thing. Where's my restream? Oh, there it is. Hold on. Put this back here, and let's fix the... Let's see if I have a little more time to fix this carbs thing before breakfast. Oh, there's one other figure I just want to send to. Cool. Every so often I just gotta do, I gotta do some random stuff like that. Answer some things. Okay, let's figure out this. I want to figure this out before. Breakfast. Let me see. So, num samples, real dim is 10. Search distribution in basic. Okay, I think that because I have this now, I just get to drop real dim. And I think that this is correct. Let's see. Found 2 different devices. Okay. This is probably just this tensor being. Where does this get transferred to a device? I don't see a device. Search radius in basic. Does this get used? This scale length is sketchy. They don't specify a device on this. Do they? Hang on. Did these somehow get moved onto GPU? Oh, there's a 2 device here. I don't know where device gets set. Yeah, so this is not a CUDA tensor. I didn't think search distribution in BASIC was a CUDA tensor either, though. Right? I don't think I changed that. Let me see. Oops. Carbs. So this is just a normal. And this doesn't have anything on it. So where is this screwing up? Underscores. I don't ever see this getting moved onto the GPU. Let me see. So search in basic equal distance. What the heck does this even do? I don't actually know what the heck this even does. This is very weird. Get probability in search space. And Jippity. I'm a little confused as to why this function exists. Relative probabilities based on their distance from a set of origin points. Okay. Maximum probability. Okay. So distance measured how far is from each origin. Distance is evaluated using log prob. Using a Gaussian have high probabilities. Okay, why the hell is that a reasonable thing to do? Okay, I don't understand why they're doing this. They already have a Gaussian process here. I wish I could just get on a call with these guys, but they're doing other stuff. Let me see if I can find this in their paper. Because to me, this doesn't make sense. This is like, I understand what they're doing, but I don't understand why they're doing it. Okay, here it is, right? Here's their distance function. This is demo. Okay, so here's their paper. Let's flip the scene over to review. Okay. Let me see if they actually, do they say anything about this scoring? Ah, is this it? Hold on. We define, I think this is it. We define the search space as a set of Gaussian distribution. So this is it right here. Candidates are suggested, but then they score them. I think we're gonna go to Claude. I'm gonna go to Claude for this. There's nothing better I can do that lets you drop in a whole PDF, right? There are no better models. I think that this is, they might have a reason for doing this, but I don't think they have an ablation, and I don't think that this is well explained. So they define the search space as Gaussian around here. If we assume we have observations, this is the Pareto front. I don't understand what this p-search is being used for. This is a little tricky. Oh, come on. Unexpected capacity constraints my ass. Am I not logged in? High dimensional search spaces. Traditional Bayesian optimizations over-explore highly uncertain regions by restricting the search space. Yeah, but that doesn't address anything. Sampling candidates around Pareto points, down weighting for some p-search. Yes. Okay, so the only thing so this is what I'm currently doing. You might have to lower the sigma values though. Like a fair bit. That's a little tricky actually. Let me think about this. Okay, so I just use this to make sure I'm not being completely stupid most of the time. Um, Basically, what I'm looking at here is the way in which we're sampling parameters. This looks good. Fixture. Larger? Yeah, so this is what I was wondering if it should be learnable. Let's see about this. Okay, I think that this should be better. Let's see. Okay, we're gonna try this. I think I found a good update to this algorithm. So we're gonna remove this completely. And then, yeah, we're gonna remove this completely. It doesn't actually even use this one here, so we can get rid of that. It does use these probabilities, it looks like. Let's see about these candidates. So here, these are the probabilities. And then where does it use these? Acquisition function. Okay, so it only uses these prior probability, central equation, acquisition function value. EI value, max cost masking. So let's take a look at this. Okay. Oops. Let me find the paper again. Where'd it go? Okay, here we are. Where's the acquisition function? This is the acquisition function. Okay, so here's the math. I have to take a second to understand this. The final model is fit only using observations that belong in the Pareto front. I don't understand why the hell you would do that. Why would you train a model just on the Pareto front like this? So they have GPY predicts performance of a candidate. Okay, this is good. Cost function, right? And then optimal performance corresponding to that cost. Predict the optimal performance, GPF, this doesn't seem like this should be a Gaussian process to me. This seems like this should be a frickin' like logistic regression. This should be like a logistic regression or something that's on like a few data points. What does a Gaussian process even give you when you do that? Let me see. So you take radial basis function. They take observations in the Pareto front. I don't understand this. This seems like a very simple regression, right? Where you just have cost and you just have cost and you have score. I think I'm going to leave this one alone for now, though. We'll play with that one later because we're changing too much stuff at the same time. Okay, so the acquisition function seeks to improve performance relative to the corresponding point on the Pareto front. With expected cost, we can use the Pareto value to write the expected improvement with respect to the Pareto front. Okay, so you have GPY, which is the performance of the candidate, minus the actual performance of the corresponding point on the Pareto front, I don't know why they take RELU. I'm going to ignore the fact that there's a RELU there. I don't know why they flip it like that, but whatever. Oh, I guess because they already have the Pareto front point, so that you can't do worse than the Pareto point because you already have it, I guess. But that's kind of weird. I guess maybe it's just they don't want negative. If they're treating these as probabilities, they don't want negative probabilities or something, though you could just normalize, so I don't know what's up with that. The final suggestion is simply a max. Oh. I don't know if that's particularly good that they take a max instead of sampling. So they multiply by p search. So this component is actually, this component looks pretty good to me. This component looks pretty bad. The next section fills in details, okay. Uniformly weights improvements across the entire Pareto front. We seek to balance sample a threshold cost from a log distribution. Okay, I gotta figure this one out. This is complicated stuff. Yeah, I mean, I'm really not that math heavy, so it's like this stuff takes a while. Hold on. All right, I'm gonna go for breakfast. I will be back in a bit, and we will continue on this. This is what I'm gonna be doing all day. I think we're gonna be able to really improve this thing because I don't think they have ablations on everything, right? Unless I'm totally wrong. Let me make sure I'm not just totally wrong. Clamping. Yeah, so they have clamping, resampling. We'll look at this when we come back. I'll make sure I'm not being stupid and that they actually have ablations on these, but my expectation is that they don't have ablations on all these little details. So I'll be back in a bit. Let me see something. For folks on YouTube, I'll be back in like an hour, but in the meantime, if you're interested in following all this stuff, all the links are on puffer.ai. You can start the GitHub, helps us out a ton. Take a look through the code there. We've got like a 900-person Discord, lots of helpful people if you're looking to get involved in RL, contributing, whatever.